My name is Carsten Kübler. I'm from TWT, and I'm the project lead of the DIN standard. I will introduce you to the standard and how we are working in the sub-project 0. So let's start the presentation. Germany has a lot of standards, and I would say the most known is DINA definition of the paper size you can find everywhere. So the benefit of having a standardized size of the paper increases the innovation and you can find it everywhere in Europe. And if you would transfer this example to the wiring harness in the automotive industry, then the question is there any wiring harness which could be used in all the cars which are manufactured by all the OEMs? You can imagine that this is not possible, and therefore we try to standardize how we could automate the different wiring harnesses which are needed for the vehicles from different OEMs. And therefore we we had to address the product itself, the production process and the equipment, the process technology. And for the automation, it's also very important how to store the information and the data. There are many questions how to automate the wiring harness. And the role and the benefits for the standardization is that we could ensure interoperability between components and the machines for the automation, because the machine may be limited a little bit more than the human beings who produce wiring harnesses right now. And for the handling of the wiring harness, the complex wiring harness products, we have to generate modules, and they have to be handled together. We have also to have the we have also to ensure the interoperability between the wiring harness and the mounting technologies which are used for the mounting. And we have also to address the engineering data of the engineering data which is related to the components, machines, and the processes. So how we started, we had already a short introduction from Mr. Rumpelt. So as you could see, we have here a figure how we increased the standard over the editions. So we started with developing of the standard in that way that we addressed design rules for different process step in the development and production of the wiring harness. And we had also addressed data formats which we use, KBL and VEC. So we also started with the design rules, and we had some design rules where we would like to give guidance, and we have also design rules where we define that they are rules which has to be used in the development process to be compatible and conform to the DIN standard. We have also addressed 3 different motivations. One is that we try to optimize the variety. That means that we reduce the number of varieties, and this is easier and automation friendlier for the tools. We have to enhance processes to have a process which is automation friendly, and we have also to improve the product that it could be maybe handled via machines. We started with our first edition and addressed only the low voltage applications of wiring harnesses. And in our second edition, we also addressed high voltage and radio frequency. As you could see, we have now the third edition, and we also address not only the application level high voltage and radio frequency. Now we extended our standard in that way that we added additional design rules for application layers. We also defined in the second edition a design of conformity, and we will extend this also in the third edition. And we also would address in the third edition, and that's new, that we define specific topics, for example, modular contact carrier or an automation RIP, which is used in the standard in design rules. So let's have a look where we are right now. The design rules are in the development process of the wiring harness. So in the wiring harness, we have the concept phase, the design phase, and the initialization phase for the production. For each of this process step, we have the design rules defined. But what is also necessary, that we have also defined design rules for the components. And only automation-friendly components could be used in the process, and therefore the automation could be achieved in the production. So let's have a look in one of these design rules, or in several. They are all defined in tables. They have all a classification of the design rule itself about a motivation and the background, so that the understanding how you could or what the design rule addresses is motivated in this header. You can also find the liability if this design rule is a rule or a recommendation. So a rule means that if you would be conform to this standard, you have to apply this rule in your development process and production process. Recommendation is not necessary guaranteed. So, and for the understanding of the design rule, we have also added an illustration what is okay and what is not okay, or if there are several different uses of the design rule, as you could see on the right, with 2 different tapes or protection components like a tape and a fabric tube. And the important part of the design rule is the requirement for the target value. So this is where we define how you could check if the design rule is could be applied to the process step, or if you couldn't apply it to the process step. And if you would like to check this digitally, then you have also the requirements for the data, which is necessary to check this with the defined data formats. This is necessary to check the target value automatically so that you can get an automatic check if the rule is achieved or if there is a failure in the design process or in the production process. There's also an information if there is an outlook how this design rule is updated in maybe the next edition. And then there is also a reference to other design rules to which this design rule is clustered, for example. If we have a look in this design rule in detail, we have this data requirements for the measurement criteria. Then we can have also not only the natural language, how to describe this data requirement, we also find in our standard the implementation in these two data formats. You can find this for the wiring harness and for the component. This is part of the standard. What we have added in the second edition is that we have also the possibility to calculate the degree of design for automation. And in our second edition, we have 3 different values for this KPI. One for the block loading process level, a second for the process level wiring protection application, and the third for the fixing part application process level. And you can find which design rules has to be addressed in this or for calculation of this KPIs, and you can calculate a conformity of the development process regarding to the block loading process level as an example. In the third edition, we will not only address low voltage, we will also address at least high voltage to calculate these formulas and to give compatibility to the or conformity to the norm for these application levels. And I will also give an outlook on the next slide that we have this in the third edition also addressed additional parts like the automation RIP and the modular contact carrier, and that they will be addressed also in design rules as displayed in this design rule. So what we have achieved right now, and I will only have a short feedback on that, is currently we are presenting, or we are preparing the English version. So it's right now prepared and it will be published very soon. And in the third edition, we are preparing the current proposals. We have a lot of new design rules. We have the design of conformity extended, and we have also proposals for the modular contact carrier and application RIP. So thank you from my side for the presentation of the TP0, and I will hand over to the next of my colleagues.